How do you know what is inside of our planet Earth? For a long time, people were wondering what is inside of the planet. There was many suggestions, there was many ideas, there was a lot of clues on the surface of the planet or in the sky that give us ideas which later we could test with science development. You'd be surprised, but back in the day, in the ancient Greece, people already suggested that the Earth is rounded by looking on the horizon, disappearing ships, by looking on the stars, rotating on different latitude differently, and by looking on the moon eclipses, when the shadow of the planet Earth fall down on the moon as a circle. Already back in the day, in the 3rd century before Christ was born, Eratosthenes in the ancient Greece discovered the radius of the planet, and it was close to the actual one. However, there was so many ideas about the shape of the Earth, what is inside, for next 2,000 years. And only about 200-300 years ago, we started having solid evidence what is inside of the Earth by development of physics, other related science, astronomy, magnetism, study of the waves, development of earth scientists like geology, and when people start traveling all the planet and take measurements in all parts of the planet, compare those measurements and making the conclusions. So as far as back in 18th century, some people were convinced the Earth is hollow. Just think about Jules Verne's Travel to the Center of the Earth novel, when he described if you go through the volcano void, you have to walk very long time till the center of the Earth, and you will discover that there's a gigantic cave inside of the Earth with the ancient animals still alive. However, physically, nobody ever been deeper than 1 or 2 kilometers into the crust of the continents, or as deep as the Mariana Trench in the very bottom of the ocean, about 11 kilometers down. Therefore, we can't see what's inside, but how people find out that? As I said, development of other related science branches helped to discover what is inside of the Earth. In particular, already back in 18th century, you'd be surprised, geologists start noticing different surfaces of the planet. We have oceanic crusts, we have a continental crust. We discover that the plates on the surface are moving. We have earthquake. We see volcanoes and the magma coming out of the volcanoes like a hot lava. So it gives us ideas there's something hot inside of the Earth. Also, people for many centuries were going down into the shaft of the mines, and they discovered the deeper you go towards the center of the Earth, the hotter it's become. So we had some indirect suggestions about it. But the flash of the physics, magnetism, the whole world exploration and use of all the sophisticated equipment in different parts in 20th century goes to the first discovery of the core inside of the Earth. And then later in the second part of the 20th century, after First and Second Wars, where there was a lot of new equipment developed to study the bottom of the oceans, to track the submarines. We could firstly map all the telemetry or the base of the ocean. Then we have a lot of new equipment to study geomagnetism of the planet, radio waves, and seismicity. All these data start being collected, and because of globalization, scientists start share this data. We start having new evidence of what is inside of the Earth. At the same time, astronomy, study of the sun, how it's formed by itself, study of formation of solar system, our solar system in particular, study of our other planets, help us to understand how our planet was formed. And we also could observe modern systems outside of our system, how they form right now. That will tell us that's what happened with us in the past. Combining all this evidence, also taking the knowledge of all the geologists around the world, study the rocks, confirming the plate tectonics, that the crust of the Earth is moving. It's separated into little parts which are moving against each other. Study of different rocks, the composition. We can know as good as composition inside deep in the Earth, its chemical composition, density, temperature, and pressure. So let's look on the seismology, which actually trigger this understanding that we have a solid core inside of the Earth, which mostly consists of iron and a little bit of nickel, very heavy metals. In seismology, people register the waves, which propagates towards the surface when the earthquake happens. So when you have your earthquake, it's not just one piece of land moving towards other, and it shakes on the surface. The actual movements usually happen deep within the crust. Shallow earthquake could be up to several kilometers. Then you have deeper earthquake, up to 20, 30, 40 kilometers, 80 kilometers, and the deep earthquakes, up to 100 kilometers. And when this earthquake happens, we feel the shaking and we can record it. There are different waves recorded during this movement, and as a result they move through the earth, through the air, through everything, and we can record it. These waves could be recorded all around the planet with some delay, because it takes time for the wave to propagate through the solids. If you think about surface of the water, if you drop a stone, you will have the waves on the surface propagate in all directions. And of course, it will take time till they reach to you on the other shore. And the bigger rock you have, the more waves you have, the faster they will move, and so on, different amplitudes. So we can record it same in our Earth's crust and figure out the properties of that Earth. Earthquakes show us not just the properties of the crust, which we know composition because we can go and dig and measure, but it's also give us ideas about composition of deeper layers. And we can check it by simulating the properties of those material in the lab. We can simulate magma, or some scientists even trying to simulate the cores and propagate the waves through and see how they behave, and then compare with what we recorded, and it will give us idea about the interior of the Earth. First time, in the beginning of 20th century, one of the scientists discovered that some waves, when they're going through the Earth, they're kind of disappearing. They're not appearing anywhere else on other part of the planet. And it looks like a little shadow of the something rounded within the Earth that suggested and then proved it that there is a core inside of the Earth, solid core. Core inside of the Earth quite big, up to 1,000 kilometers the solid part, and outside is a couple thousand kilometers thickness of the liquid part. And when they propagate the waves, they behave differently, going through and disappearing totally, some waves when they're going through the solid core. It was a solid suggestion, and after the World War I, during the World War II, it was proved by other scientists that it's true. All the other related researches, like geomagnetism, study of astronomy, as I say, they all prove that. And already when in the 20th century we figured out how our solar system, more confirmed theory how it was formed, there will be other video about that, it's logically fit in with idea about the core and the Earth. And even observation on the planet's surface proved it. We have hot lava coming out of the volcanoes, which is sourced from the magma, this melted material within the planet till it reached the core. We have convection within the magma, which causes the crust moving. We can logically assess that the more heavy metals, when our planet is spinning, will of course sink down into the very bottom, like it's happened with the core and outer core. And the lighter materials, which more in the magma, this thick layer between the core and the magma, and in our crust, mostly very, very light materials, they will go more towards the surface. So when you spin something, kind of like in centrifuge, you will have this layering happening. The heavier materials go towards the middle, the lighter stuff will go to the sides. And that's exactly what happened to our Earth. Remember that our Earth keeps cooling down, same like a solar system and the sun. And if you think about the climate, there'll be video about this effect on the climate. We are now in the most cold period of the history of our Earth. We have the periods of glaciations last several million years, which confirm that the core of our planet is cooling down. So what is inside of our Earth? Please watch the following videos, but we can know for sure that when our planet was formed, about 4.6 billion years ago, it started cooling down, it kept rotating, the heavy metals sinking towards the middle, forming the core, and there was this still moving magma mantle, which is hot melted materials of mostly heavy metals, but a little bit of lighter materials there as well. And we have the crust on the surface, very, very thin layer, up to 200-300 kilometers, which is very small in comparison with the radius of the Earth, more than 6,500 kilometers. If you look on the apple, you can imagine similar structure with the Earth. Thin layer could be the skin on the surface of the apple, then you have nice flesh, magma, and within you have a centerpiece with the seeds, which is our core. So what will happen if we start going down towards the center of the Earth? Before we reach several kilometers, we probably will just die from overheating. Especially when we reach the asthenosphere, the high layers of the magma, which is several thousand degrees high temperature, will be just melted. So even if we really want to go into the center of the Earth, I don't think it's possible.